So, we are now looking at indefinite integration. You would have learned the rules for differentiating power functions. And so now we're going to look at the reverse. So I've drawn a little graph there, and we're going to look at why this needs one or two things. So it needs c as an arbitrary constant, which is demonstrated now. So we have x squared and then x squared plus something, and then x squared minus something, let's say. And if you differentiate each of them, you will get 2x. And so there's something missing. They can't all be the same answer. There's more to this. There's an infinite number of functions when we differentiate and get 2x, for instance. And there we see n cannot be equal to minus 1. That's because we have another issue later on, and that will lead to the natural logarithm specifically. So let's do a few examples. First one there, we don't have to rearrange anything, which is nice. So x to the power of 4, now looking at your formula, you'll have to use your formula strictly for the first few examples, definitely, when you're doing this. But eventually you get used to the idea, you'll see the trend of it. Put in your plus c there as well. I've put it in a different color just to highlight there. And now just simplify. So 1 over 4 plus 1, and then x to the 4 plus 1 is 5. So there's one example of that. And the next two examples will be rearranged. So you should already know that power and a root can be problematic with some questions in exponent-based questions, logarithms and differentiation too. So you've seen this before, just be careful with them. Again, you can see there 1 over. 1 half plus 1 is 3 over 2. At the very beginning of this, you might change everything into a fraction. 1 half plus 2 over 2, maybe. It depends on your method of learning. You could have rewritten this example as well as x to the 3 over 2 or root x to the 3. Last one there, when you see any fractional ones, you're going to have to rearrange them. You don't have to, but at the beginning it's just way easier. So you should. Eventually you probably don't need to. For most of the easy ones anyway. 1 over minus 3 plus 1 is minus 2, x to the minus 2. And again, we're going to rearrange this one properly, just so you can see it. So minus 1 over 2 to the x. So 2 to the x squared, we're going to put underneath there. So that's that part from part B as well that we were showing. And just, you can rearrange it because it leads into the next question or the next part more easily. Okay, part B. This is a more expansive example. We have x minus 2 and x plus 5. So let's multiply them together, as you know already, using your FOIL method, if you will. And then root x is x to the power of a half. And now, after rearranging it, making it nice to deal with, we can start to do this. So dy over dx, we're trying to find y again, of course. This part here, just make sure, just simplify everything and separate out the terms. Okay, so separating out the terms just makes it way easier when you have to divide by a denominator, as you see. So we had x to the power of 2 minus a half, which is 3 over 2, and 3x divided by x to the half, which is a half, and then of course minus 10 x to the minus a half. And as you can see, I'm writing currently, we're actually integrating there, so 3 over 2 plus 1 is 5 over 2, and so on. And just little tricks with fractions here, you'll get used to them, but let's say you have 1 over 5 over 2, just flip it. You can flip that. You can check your calculator with these things as well, of course, and just see if you can notice any conventions or any norms with that kind of stuff, with the exponent rules and with fractional and forms and so on. So there we've just put on our final answer for that one. Shouldn't be too taxing. It's good practice for your algebraic skills as well, to be honest. A lot of calculus is just a lot of algebra when it really comes down to it, even at university level and beyond. Part C. So a curve is such that dy over dx is equal to that function there, And given that the curve passes through a point, minus 1 and 10, find the equation of the curve. So this has got a little bit more, this last example here. So now we're just going to simplify it again. And I'm rearranging the two in one go. I won't do all the little in-between bits. So 2x is x squared. Let's just do it fairly quickly. And there you'll see the same for the second term as well. Be careful with the fractional ones and just take your time with them. So that's the same form as 6 over x. And of course it's minus, because of the minus 1 on the denominator. So x squared minus 6 over x plus c. Now we're going to be able to find c in this question, because we were given a point. So y, as in 10, is equal to minus 1 squared minus 6 over minus 1 plus c. So we end up with minus 1, nope, plus 1, be careful there, and then plus 6 as well. So just make sure those signs are correct. And of course 10 minus 7 is 3, so c equals 3, and then at the very end just rewrite your equation of the curve to make it clear for your examiner or to lead into the next question with confidence. So that's our introduction to indefinite integrals. We will be doing more of them, and then we'll also be looking at the forms of ax plus b to the n, exponential functions, briefly, the sine, cosine, and secant squared functions, and also lastly we'll be looking at the integration forms of functions for what you saw at the beginning, 1 over x and 1 over ax plus b, which are to do with the natural logarithm. And after that, you're finished more or less for this course with indefinite integration, and you'll lead into definite integration.